In this video, we shall be designing a buffer. That is the second experiment of your part A. So, buffer is a circuit which provides the same output as your input. That means whenever you apply a logic 0 as at the input, output will also be logic 0. If you apply logic 1 at your input, the output will also be logic 1. That is the role of buffer. When you are getting the same output as your input, then why we need a buffer? That is the question, right? So buffer, it is used for restoring the values. Mainly buffers are used for restoring the values. So to get a complete logic 1 or logic 0, we make use of buffer for restoring. It is simple that it is used for restoring the signals, that's all. So as we discussed, any design should start with a module and it should end with end module. Here the module name what I have given is buffer. I given a module name as a buffer, and in the port list I have declared A and Y. A acts as the input and Y acts as the output. So next we have to write assign y is equal to a end module. So this is the program for your buffer. Now we have to write a test bench for this particular buffer. So as we discussed, for writing a test bench, it should start with module and end module. Module name I have given as buffer underscore tb. Tb indicates test bench. So you can give any name. It is not necessary that you have to give buffer underscore tb itself. So next input should be declared as register, output should be declared as wire. Next we have to make use of this buffer as a component into your test bench. So I've written buffer, the same name as your design. Once you write the name, same name, automatically this particular module will be taken as a component into your test bench. For that, in this process is called as instantiation. Once it is instantiated, you have to give some name for it. So I'll give buffer underscore ins. This is again, this is buffer underscore ins. You can give any name. It is not necessary that you have to give buffer underscore ins itself. And then we have made a port mapping. Here I've port mapped by order. A is connected here, so we have connected A. Next is Y, so we have connected Y. Okay. After instantiation, we have to apply the various inputs at different time slots. So we will declare that in the initial block. So this is a procedural block which executes only once. Since we have many statements inside this initial block, we have used begin and end. So at time 0, a value I have given as 0. At 10 time unit I have given a value as 1. At again after 10, a value will become 0, and after 10 a value will be 1. Okay, this is about your buffer. When you execute that, you can see here when it is 1, when your input is 0, output is also 0. When your input is 1, output is also 1. Again 0, 0, 1, 1. So whatever input you are providing, the same will appear at the output. So we shall design this using Xilinx, and we shall verify the output. So open your project navigator. As I told, go for implementation. Right click, you can see the IC here, right? XC3S, click on it, and then click perform right click. You can see a new source. Go for Verilog module, give the name as buffer. Next, we will ask for input and output. Here I have given input as A, output as Y. So here output should be Y. Next, finish. Once it is done, you just write assign Y is equal to A. That's it. Save it. See here, still it is in inverter. So click on for or right click on it. You can make it as set as stop module. Okay, once it is set as stop module, you can see all these options. Now you have to synthesize it. So there is a tick mark here. See, as I told, all the keywords should be in small letters. If you give in capital, any one character as a capital, see here I have given M as capital. Once I give in capital letter, this won't be considered as a keyword. It will be showing error. So all the keywords with the name with blue color will be considered as keywords. So here it is showing error line 21 module. Okay, so this should be a small letter. Once you write give a smaller letter, it will turn into blue color, which indicates it is a keyword. Once you synthesize this, what we have to do, the next step will be, you can go for RTL schematic. So it uses the technology files for generating your input and output. So this is a buffer. Go for technology schematic. Here you can see buffers. This is the technology what it has used inside. Okay. After doing this, we have to write a test bench. For writing test bench, we have to go for right click on the buffer, go for new source. Here Verilog test fixture. Here you can give the name buffer underscore tb. Next, see here in this particular folder Verilog HDL lab, there are two programs, one is inverter and one is buffer. So for which program you want to create a test bench, that will be asked here. So I'll be selecting buffer because I'll be writing a program for buffer. So I'll just click on buffer and put next and then finish it. So when you do that, automatically this program will be generated. Okay, input will be declared as register, output will be declared as wire, and next instantiation and port mapping will be done automatically. Initial value of A is 0. Next we have to give different values of for A. So in the initial and begin, we have applied different inputs at different time units. This 10 time unit A value will be 1, at 20 time unit A value will be X, and at 30 time unit B value is A value will be Z. So click on this buffer, go for simulation window, click on this test bench and then run it. So you'll get a green color tick that indicates there is no syntax error. Then you have to run this particular simulate behavioral model. So zoom to full view. Here you can see the output. So when you apply 0 at the input, output is also 0. When you apply input as 1, output is 1. And your input is unknown, output is also unknown. And when your input is high impedance, output will be unknown. Okay. This is for your behavioral modeling, design of your buffer. In the next video, we shall see design of transmission gate. Thank you.